Welcome to the module on arrays. In this module, we begin to talk about arrays and their functionality, without including arrays of characters. You're going to be learning how to declare them and the different ways to initialize them. We're also going to be discussing how to access the different elements of an array and the different ways to process their contents when reading and writing or doing mathematical operations. And finally, how arrays work in memory and the different cautions you must take when using them. Previously, variables could only hold up to one element. Here, we're going to learn how with an array we can store multiple elements of the same data type in a continuous sequence of memory that can each be accessed individually. With all the variables you've seen up to now, they've had a fixed memory size that can be seen in the table below in the column Size of Element. With an array, you declare the size of the array using a constant or a literal, because once it's created, you cannot alter its size. Now we can In the declaration of an array, the number inside the brackets is called the size declarator. If we have an array called numbers with a size declarator of 5, that means that the array numbers has 5 elements. Each element can be accessed by using their subscript, an assigned number. The program that you have on your left asks you to enter your phone number and then it repeats it back to you. On line 6, I declare a variable called phoneNum that's an array with a size declarator of 7. Up next, the program then asks the user to enter a phone number, and you'll notice a cin to phone number being done 7 times, each with a different subscript from 0 to 6. And then it prints the message the phone number is. Then it prints the contents of each subscript, going subscript by subscript again. Another way of doing this without having to write the array name 7 times, once for each subscript, is to loop through the subscripts. In this case, any loop would do. It could be a while loop that runs 7 times or a for loop. For this example, let's use a for loop. Now, what used to be 7 lines of code is down to only 2 lines of code. What you're going to do is make a for loop and initialize I to 0 to represent the subscript in the array, and the loop will continue till I is 1 less than the number of elements in the array, and finally I increments by 1. Next, I added I inside the brackets of the array. Here, we're going to learn the different ways to initialize an array. First, on line 8, I created an array called numbers with the variable count as the size declarator containing the number 4. So this array has 4 elements. To initialize it, you need to enter 4 values of the same data type as the array, which is an integer. These four values will be separated by commas and encased in braces. And for this example, I initialize the array with the values 3, 5, 7, and 9. Next, we have partial initialization. First, I declared an array called values of data type shortInt with a size declarator of 4, except this time I only entered 3 values instead of 4. I entered the values 1, 2, and 3, and what's going to happen is that any extra element not initialized will be automatically initialized to 0. Now note, you cannot skip a number by writing 2 commas in a row. This will result in an error. Then we have implicit array sizing. On line 12, I declared an array of type double called digits, but I left the brackets empty. So at the time of initializing it, the array will automatically size itself to the number of elements that were used to initialize it. In this case, it's size 3 because it was initialized with a 2, a 4, and a 6, only 3 elements. The problem with implicit array sizing is that later, to print the arrays using a loop, you must know the size of the array. Now we're going to loop through them all. For this for loop, I started the count at 1, and it's set to stop when it reaches count, which is 4, and it increments by 1 each loop. The following cout statement prints I, and then there is a tab, then the first element of the array numbers is printed by subtracting 1 to the subscript since the first element is in subscript 0, not 1. After that, it tabs again and prints the first element inside the array values, then tabs again and prints the first element inside the array digits, and then there's an end line. On the right hand side, where the program output is, we can see that a 1 was printed, followed by the first number in all the arrays, a 3, a 1, and a 2. The for loop will keep incrementing I and printing the elements in the array. And when printing the fourth element in the array on the fourth line, we can see that the last element, the number 9, was printed in the array numbers. The last element in the array values was also printed. It was a 0 since it was partial initialization. And finally, we see a really long negative number. Since in the implicit array sizing only 3 elements were declared, when it tried to print a fourth element, it just went to the next space in memory and printed its contents, and that long number was what was there. Partial initialization. In this program, we're going to practice doing different algorithms. First, we're going to enter 5 numbers, and then we're going to find the average number entered. On line 6, I entered a const integer variable called size and initialized it with 5. Then I declared 3 integer variables, an array called numbers with a size declarator of 5, another variable called total initialized to 0, and a third called high. Next, I declared a double variable called average. Now the user enters 5 numbers using a for loop. The for loop says that I equals 0. The loop stays running till I is less than or equal to size, and I increments by 1. This right here is known as an off by 1 error. Why? Because if the loop stays running till I equals size, then the program is going to ask the user to enter a value for the array numbers using a subscript of 5, which would be the 6th element of the array, but this element only has 5 elements. So if a value is entered, it will automatically overwrite anything that is in the following block of memory. C++ doesn't check for situations like these, and it just does as it's told, so we need to be careful. So for this loop, let's input the values 2, 6, 4, and 1 as an example. And on line 13, there's another for loop that will loop 5 times. And inside the loop, there's an expression that says total will be assigned the result of total plus the array numbers. Remember that currently total is initialized with 0. So for the first loop, total is assigned 0 plus 2, 2 being the first element in the array, and now total equals 2. On the second loop, it'll read that total is assigned 2 plus 6, which is 8, and this will continue till it's looped through the entire array. And then when it leaves the loop on the next line, it's going to assign to average the division between total and size, total being the addition of all the numbers in the array, and size being the number of elements in the array. And you've successfully stored the average in the variable average. Next, let's get the high number between the 5 elements entered. To do this, let's compare all the values using an if conditional statement. Now first, let's grab the first element of the array and save it as the current highest number. Then in the for loop, instead of starting at 0, we can start at 1, since we've already stored the first value as the highest. And inside the loop, there's an if statement that checks to see if the following element is larger than the current highest element. If it is entered and that number is stored as the highest. By the time it's done looping through all the elements, high will contain the highest number that was entered. If you want to know the position of which the highest number was stored in, simply make another variable and store I inside of it. Now we're going to learn how to pass an array as an argument and how to assign the contents of one array into another. The first thing you must know is that, as I mentioned previously, an array name without brackets holds the address of the first element of an array. When arrays are being passed as arguments, they are always referenced. Any changes done inside the function will alter the original arguments. On line 4, we have a function prototype called assigning array. We can see that this function accepts 3 arguments. The first 2 are arrays. A single dimension array being sent as an argument must always have empty brackets.